guys to this session. So in this session we are going to see determinants. As I told you, determinants is a very important chapter as far as the board exam point of view is concerned, because you have got 9 marks totally for determinants. So it is a very important chapter. So I have given you I am going to give you some very important concepts and also very important numericals as we did for matrices and also for ITF. So in those concepts and in those numericals, if you have got any doubts, you can feel free to book a session with me and then try to clarify all your doubts. So now we are going to go directly into the session. We will be having many subsequent sessions like this. So all the very best. Do well. Let us collectively rock together. Take care. Yes, in this session we are going to see determinants. So we will see all the important concepts and some of the important models of questions that can appear for your exam. So now let us go into this chapter. So determinants is applicable only for a square matrix, that is which has equal number of rows and columns. For any other type of matrices, determinants is not applicable and it has got a certain value. I am sure that all of you would have been aware of how to find the value of a determinant now. So determinants. So the important topic in this chapter, straight away we go to this area of a triangle. First exercise is about expansion of determinants, which everybody would be knowing. So we go to area of a triangle. So you would have known the formula for area of a triangle, which is half determinant of x1 y1 1 x2 y2 1 x3 y3 1. And when you do this, there will be vertices given, that is x1 y1 x2 y2 and x3 y3 will be given. So if you substitute these values and then expand the determinant, you will be getting the final answer. And if you are substituting the values and if you are getting the answer as 0, suppose if A area of a triangle equal to 0, then that means the given points are collinear. Given points are collinear. So this is based on the collinearity, and also to find the area of a triangle in general, questions will be asked. Okay, next after this comes the another important concept called minors and cofactors. Minors and cofactors. In fact, I will club all these topics: minors, cofactors, adjoint, and inverse of a matrix. I will club all of them together. Inverse of a matrix. Now we will solve one question. To understand this concept better, we will solve one question. So find the minors. Find the minors. Example, find the minors and cofactors of 1 minus 2 4 3. 1 minus 2 4 3. This is a 2 cross 2 determinant. So the same principle applies for 3 cross 3 also. So we'll solve for 2 cross 2. So now we'll first find out the minor m11, m12, m21 and m22. So now m11. This is the first row. This is the first column. So you cover this first row and first column, you get 3. Similarly, first row, second column, first row, second column, you get this. You cover first row and then second column, you get this 4. And second row, first column, second row, first column, if you cover, you get minus 2. And second row, second column, if you cover, you get 1. So cofactor matrix is cofactors, very simple. So we call A11. For you add this 1 and 1. If you get an even number, the cofactor value will be the same value as the minor value. Suppose if you get an odd number, you will have to change the sign accordingly. So here 1 plus 1 is 2, which is even, so the same value you have to write. Similarly, A1, 2, this is odd, so you will have to put a minus and then write it as minus 4. And then A2, 1, this is again odd, you will have to change the sign and then write it as 2. A2, 2, since it is even, you can write the minor value as it is. So this is the cofactors. Now write a cofactor matrix, which is Aij, which is 3 minus 4, 2 and 1. 3 minus 4 and 2 and 1. Now this is a cofactor matrix, so put a box for this. Now we are going to see the adjoint concept. Adjoint of A is nothing but cofactor matrix whole power transpose. It is in fact the transpose of cofactor matrix. So transpose means interchanging rows and columns. So if you interchange these rows and columns, you will get 3, 2, minus 4 and 1. So this is the adjoint. Adjoint of A is nothing but this matrix. 3, 2, minus 4 and 1. Now A inverse. A inverse is nothing but 1 by determinant of A into adjoint of A. First you find out the determinant of A first. You find out the determinant of A. Find out the determinant of A first. I'll erase this. I'll erase and write it again. Yeah. So now if you find the determinant of A, you will get 3 plus 8, which is 11. So determinant of A gives you 11. So it is 1 by 11 of this value. 3, 2, minus 4 and 1. So you will be getting the final answer A inverse as 3 by 11, 2 by 11, minus 4 by 11 and 1 by 11 respectively. So this is the inverse of a matrix. So this is how you have to find out the inverse. I am sure that all of you would have been able to understand this concept. So minus, cofactors, adjoint and inverse. So we have seen it for a 2 cross 2 matrix. 3 cross 3 matrix is very similar to this. 3 cross 3, you will have to evaluate the determinants. You will have to evaluate the minus first by evaluating the determinant, and then cofactors you will have to just check the sign, and if you add the values and if you get an even number, then you should retain the same as like a minor, and if you get an odd number, you should change the sign of the minor value. So and then you have to construct a matrix. That is called cofactor matrix. Transpose of that matrix will give you the adjoint, and after that you will have to do the inverse formula. First of all, for inverse, I forgot to tell you one thing. For inverse to exist, I'll write it in the next page, or I'll write it in the previous page itself, because the previous page I have written, I haven't written the formula. So A inverse, I'll write the formula once again, and then I'll explain you guys. 1 by determinant of A into adjoint of A. For inverse to exist, determinant of A should not be 0, because if it is 0, then it becomes a singular matrix. So 1 by 0 becomes infinity. So the inverse will not exist. So determinant A should be non-zero. So this is the condition, and with this minus, cofactors, adjoint and inverse is over. And after this topic comes your final exercise. Final exercise of your chapter, that is applications of matrices and determinants. Here you have matrix inversion method, that is they will be giving you an equation, matrix inversion method, matrix inversion method. Suppose I will teach you an alternative technique for this also. Suppose if there is a question like this, 2x plus 5y equal to 1, 3x plus 2y, 3x plus 2y equal to 7. For this, if you want to solve it in matrix inversion method, suppose you will take an augmented matrix, you will try to express it in augmented matrix, which is Ax equal to B. A is nothing but the coefficient of x and y, so which is 2, 5, 3, 2. You will try to construct a 2 cross 2 matrix for this, and capital X is nothing but column matrix of x and y, and B is nothing but this value, that is 1 and 7. So this gives you x is equal to 1 by a. 1 by a can now be written as a inverse into b. So x is equal to a inverse into b. So this is a. So for this matrix you will have to construct the inverse and then multiply with this value to get your final answer. And after that you will have to equate. So this is matrix inversion method. This is called matrix inversion method. There is one more method of solving this. That method seems to be very simple, so I'll explain you that method also. For CBSE students, you might not be aware about this method. That method is called Cras Rule. The method I am going to teach you now, that is called as Cras Rule. Cras Rule. So the same question I am writing here, which is 2x plus 5y equal to 1. 2x plus 5y equal to 1 and 3x plus 2y equal to 7. So we will find out delta. Delta is nothing but the normal A matrix, which is nothing but coefficient of x and y. So 2, 5, 3 and 2. So if you do this expansion, you get 4 minus 15, which is minus 11. And delta x you need to find out. Delta x for this, what you have to do is, y column you keep it as it is, 5 and 2. And for the x column, instead of this 2 and 3, you have to replace this b value and then write 1 and 7. Now you expand this determinant. So you get 2 minus 35, which is minus 33. And delta y, for delta y, you need to keep the x value as it is, 2, 3, and change the y value. Instead of 5 and 2, you will have to write it as 1 and 7. Now if you expand, you get 11. So now the formula is x is equal to delta x by delta. If you do that, you get 3, and y is equal to delta y by delta. If you do that, you get minus 1. So answer is x is equal to 3 and y is equal to minus 1 for this question. I am sure that now all of you are able to understand this Cras Rule. So if you can practice this method well by solving a lot of questions, you will be able to understand it much better. Now that's all about this topics, and now we'll go to the questionnaire session. I'll be telling you some important questions, just like how I told for matrices yesterday. So important, the same questions you can practice for your exam. And if you have any specific doubts, I have given you the WhatsApp number in the description, so you can contact me over there and book a online session wherein we can see the solutions. If you really need it, you can always free to contact me. You can always feel free to contact me. Okay, now we will see the important questions. Under each exercise, I will be giving you selected important questions. So in the first exercise, exercise 4.1, there are not much of questions because it is a very simple exercise. So you can just practice. They will be giving you some 1 mark questions in this exercise. So second lab, first sum, and then 8 sum. So that's all in the first exercise. Second exercise is already deleted. So properties of determinants. So directly we can go to the third, which is nothing but the area of a triangle. So before that, you can practice examples 17 and 18. Example 17 and 18. And in exercise 4.3, and in exercise 4.3, you can practice the second sum. They have given to prove it as collinear, so the area of the triangle should be 0. And then after that, you can practice the fourth sum, both the subdivisions, and then that's all. And now in exercise 4.4, which is nothing but minus and cofactors. So you can practice the 3 cross 3 sums. So you can practice the second sum 4.4 second, only one sum. Now we go to the adjoint, and before that you will have to do example 23, and after example 23 you have to remember all these things, because all these things will be coming under 1 mark. That is theorem 1. Theorem 1 you will have to remember it for 1 mark, and then this example 25. Example 25 is very important, and hence so is example 26. So 23, 25 and 26. So in exercise 4.5, you have third sum, fourth sum, and then seventh, and then 12, 13, 15, yeah, and now last exercise 4.6. Before we go, you can practice example 28 also, and example 29. This is a word sum, so word sums are also important. Exercise 4.6, just 2 sums you can practice, one in 2 cross 2, another one is 3 cross 3. So you can practice the first and the 6th sum. That's it. The chapter is over. The solution is, I have given you the important questions also. So by practicing these questions, you tend to get more knowledge and more practice in determinants. So we'll continue with the next chapter tomorrow. So all the very best to all of you. I hope that this session was really useful for you guys. So all the very best. We will see it in the next session. Thank you. Will fall apart.